This video was made possible by StruSoft. Next thing to do is to create point supports for the frame. Easiest way to create supports is to use pointSupport.hinged or pointSupport.rigid components. You can either input a point or a plane. For the rigid supports plane, I have flipped a normal XY plane by inputting the world set vector to the y-axis of the plane component. We have also provided identifiers for the supports to imply the type of support they are. This is how they look in the FEM model. We have the hinge support here and the rigid support here. These components will use the default rigid values for the springs. The pinned support obviously has 3 rotations. If you want more control over your point supports, you can use pointSupport.simple component. With this component, you can toggle between rigid and hinged values with Boolean inputs. This way you can quickly create different combinations of supports. If you require absolute control over the supports, use pointSupport.construct component. You can connect the motions.construct, rotations.construct, motionsplasticlimits.define and rotationsplasticlimits.define components to define a point support that is exactly the way you want it to be. The motions and rotations components allow you to define linear and rotational springs in both positive and negative directions. Hover over the inputs to see what units need to be used. Let's say I want to create a support that only works in positive x direction and has a spring of 1000 kilonewtons per meter. I will input the value 1000 to the x-pos input of the K motion. I will use the value 0 for the negative direction. This is also the default value, so it's not mandatory. I also want to set up a plastic limit for the support. First, check the unit, kilonewtons. I want to use the value of 500 kilonewtons for the limit. Let's edit the model a bit. I will add a beam here and a load of 200 kilonewtons at the end, and I will run the analysis. Let's see the translational displacements. In x direction, we get a displacement of 200 millimeters as expected. If we edit the load and set this to 501 kilonewtons, add a load combination, run a plastic analysis, we see that the plastic analysis does not converge because our limit was set to 500 and our force was 501. This means the support kind of broke from the load and the displacement was infinite. If we rotate the load and rerun the analysis, we see that the displacement is also infinite before the plastic limit because the x-negative motion is set to 0. Use these components with extreme care. First, analyze and verify the kind of support that you are planning and how flexible it is, and then precisely check that you input the correct values of stiffness into correct directions. Being precise is the prerequisite for getting accurate analysis results.